This is Sharma solution, class 12. Chapter 6 we are looking at determinants, exercises 6.1. Write the minors and cofactors of each element of the first column of the following matrices and hence evaluate the determinant in each case. So we are talking about the first column only. All of it we don't have to do. The first column. So let's take the first one. And those who are not much aware of minors and cofactors, I'll just give you a brief idea that how the minors and cofactors are constructed, what they mean. So let us write this 5, 0, 20, minus 1. This is the first one we are doing. So when we find out the minor, what do? We don't even think about sign. Okay. So this is 2 by 2 matrix, that is 2 rows and 2 columns. A11, A12, A21, A22. So 2 row, 2 column. A11 is 5, A12 is 20, A21 is 0 and A22 is negative 1. Right? Okay. So in order to find out the minor, as I said, no sign plus or minus we talk about. So in order to find out the minor of A11, the intersection of the row and column where A11 belongs is left. Only A22, that is the only left one, is the minor. So A11 minor is A22. So let us write it here: A11, A12, A21, A22. So minor of A11 is A22, and minor, that is the minor of 5 is negative 1. That means this one. So minor of 5 is negative 1. Coming to A12. Similarly, A12, the row and column intersecting A12, that has to be left, all the members, only the remaining one has to be written. So A21 it will be. So A21 it will be. So minor of A12 is A21. So minor of 20 is 0. Similarly, A21 will take. A21. Row and column we will leave. Only A12 is remaining. So the A21 minor is A12. So minor of 0 is 20. Similarly, A22. Row and column intersecting A22 we have to leave. Only A11 is remaining. So the minor of A22 is going to be A11. Right? So minus 1 minor is 5 here. So we got all the minors here. Negative 1, 0, 20 and 5. Okay. Now in order to find out the cofactor, we have to include the sign. The sign with minor is cofactor. So cofactor, just write the minor like this. Minus 1, 0, 25. And now it has to be added with the sign. And the sign would be minus 1 to the power I plus j. That is minus 1 to the power row number and column number. What is the row here? 1 row, 1 row column. First row, first column. Here minus 1 to the power first row, second column. 1 plus 2. Minus 1 to the power second row, first column. 2 plus 1. Minus 1, 2 plus 2. Second row, second column. Now remember one thing. That minus 1 to the power even will always give you 1 and minus 1 to the power odd will always give you negative 1. Okay. So this is minus 1 to the power 2, that is even, it will give you 1, and 1 into minus 1 is nothing but minus 1. So the minor and cofactor remains the same. In case of minus 1 to the power 1 plus 2, you get minus 1 to the power 3, that is going to be negative. Negative 0 is 0. Now minus 1 to the power 2 plus 1, that is minus 1 to the power 3, that is going to be negative 20 it will be. Finally, minus 1 to the power 4, that is going to be 1. 1 into 5 is 5. So these are now these are the cofactors now. So in order to find out the determinant, there is just in 2 by 2, just multiply 5 with minus 1 and subtract it with 20 and 0. This is 5 into minus 1 minus 20 into 0. The determinant will be like this. So negative 5 minus 20 is negative 5. So determinant will be negative 5. So let us take a 3 by 3 matrix here, one of it, so that we actually try to find out the determinant also. So we'll try to find out the minor and cofactors, and then we'll find out the determinant as well. Okay, let us take the third one. I hope you'll be able to do the second one also. So we are taking the third one. Same thing you have to do. You have to use this column. Only the minors or cofactors of this column has to be computed. So this is 3 column and 3 row. 1, 2, 3, 1, 2, 3. 3 column, 3 row. So you have A11, A12, A13. A21, A22, A23, A31, A32, A33. 3 row, 3 column. Now, in order to find out the minor of A11, the rows which are intersecting this, where A11 lies, row and column, it has to be left, others have to be written. That is, you have to write A22, A23, A32, A33. So, let me write the direct value here. So, it will be -1, -1, 2, 5 and 2. This is going to be A1. Now, coming to A21. So, the minor will be leaving intersection of A21, row and column, other value has to be written. That is -3, 2 and 5 and 2. A21. Now, coming to A31. Okay, row and column of 3 has to be forgotten, and only -3, 2, -1, 1 has to, -2 has to, -1, 2 has to be written. The determinant of 2 by 2 is simply 2 into -1 minus 5 into 2. Okay, that is the cross multiplication actually. -3 into 2 minus 5 into 2. Here it will be 2 into -3 minus 2 into -1. So it will be plus here. Okay, so what do you get? -2 minus 5 to the 10, that is going to be -12. -6 minus 10 is going to be -16. And this is going to be -6 plus 2, and it's going to be -4. These are the minors. In order to find out the cofactor, we have to take the row and column numbers and raise to the power -1 and add them. That is the thing you have to do. So -1 to the power I plus j, -1 to the power 1 plus 1 here -1 to the power 2 plus 1, and -1 to the power 3 plus 1. 3 plus 1. Okay. So only one will change, because it is only one sign will change. Why? Because cofactor is about multiplying the minor with the sign. Sign is -1 to the power 1 plus 1. -1 to the power even will always be 1. -1 to the power odd will always be -1. -1 to the power 1 plus 1, that is 2, is 1. So -12 will come. -12 will come. That is the cofactor. Now -1 to the power 2 plus 1, 2 plus 1 is 3, -1 to the power 3, that is the odd number, that is going to be negative. So negative, it will be negative, so positive 16. -1 to the power 3 plus 1, -1 to the power 4, so it will be 1 only. 1 into -4 is -1. So these are the cofactors. Okay. Now the determinant can be computed easily. 1 into minor plus 4 into minor plus 3 into minor, or -4 you have to use in minor. In cofactor, 1 into cofactor plus 4 into cofactor plus 3 into cofactor, right? Let us take the fourth one now. So we are taking fourth one. A11 is what? Row and column of 1 has to be forgotten. Only rest has to be written BC, CA, AB. And then we have, this is, let us write it as M11 because it is minor. M21 is second row, first column. Second row, first column. Be A, B, C and C, A, B. Now coming to third row, first column. So it will be A, B, C and B, C, A. B, C, A. So just cross multiply because this is 2 by 2. So you have to find out the determinant here. B into AB minus C into CA. Here A into AB minus C into CB or BC. Here A into CA minus B into BC. So you have B, A into B square. So you can just take common A because A is common here. So A B squared minus C square you can write. Then in this case you can take B common. It will be A square minus C square. B common you can take. A square minus C square. And then we have this C outside. You get A squared minus B squared. Okay, now these are the minors. So in order to find out the cofactor, we just have to multiply it with -1 to the power I plus j. I plus j is simply the row and column number. So this will be -1 to the power 1 plus 1, -1 to the power 2 plus 1, -1 to the power 3 plus 1, -1 to the power 2, -1 to the power 4 will remain like that, -1 to the power 2 plus 1 will be negative. So only the middle one will become negative. So multiplying first and third by 1, the middle one with -1. So the cofactor will be this whole and cofactor first m11 m31 will remain same as minor, but the cofactor of third one m21 will be b. I'm writing it as c square minus a square. It will be because it will be multiplied by negative 1. So I just change a square minus c square is c square minus a square. So in order to find out the determinant, we already have everything. Either you use the traditional way of finding the determinant, right? Or you can just, because what you have to do is, one, take the cofactor, then then a, then cofactor, then bc, then cofactor, but you have to write minus in front of a. But since you have found out the cofactor already, you don't have to worry about the sign now, because sign has already been covered up, right? So in order to find out the normal way, you have to do minus plus like that. But cofactor, because sign has already been taken care, just multiply 1 by cofactor a into b square minus c square, then plus, don't worry about sign, don't make negative, plus 1 into b into c square minus a square. Please remember, it is b into c square minus a square, since we have multiplied it by the minor with negative 1. So b c square minus a square, then we have c a square minus b square, c a square minus b square. So you can just rearrange them and the answer will be final. I hope you'll be able to rearrange them, because rearranging is not a big issue. Rather, let us do it so that you understand it, how actually the answer comes. So let us actually do it. So multiplying this a with b square minus c square, it will be ab square minus ac square plus bc square minus ba square plus ca square minus cb square. Now you just take a square common from a square c and ba square, that is this a square. So I am taking a square common, it will be c minus b. Okay, then you take b square common, and then you have a minus c here. So it will be b square a minus c here. Okay, now c square, you will get c square b minus ac square, so c square ab minus a. So this is the final answer. So please remember, cofactor, once you have found out, you don't have to worry about the sign. But if you are doing it with minors, then always you have to worry about the sign, because everywhere it has to be minus or positive depending upon minus 1 to the power I plus j. Okay, this I hope you'll be able to do. This one, let us do it. This sixth one. So I'll just write directly. I'm doing the sixth one, vi. Okay. So sixth one, we are trying to find out the minors here. So M11, it will be row and column of A has to be left, only BF, FC will be there. This is M11. Then we have M21, second row, first column. So you have H, G and FC. Then we have M31. So we have third row and first column has to be left, HG, BF will be there. HG, BF. Okay. So this will be BC minus F square. This will be, this is just a 2 by 2 determinant I am finding out. HC minus FG, FG actually. Then we have this one, HF minus BG. HF minus BG or GB. So in order to find out the cofactor, you just have to multiply it by minus 1 to the power I plus j. So only minus 1 to the power 2 plus 1 will be negative. Otherwise, the M11 and M31 will be positive, because it will be minus 1 to the power 2 and minus 1 to the power 4. That is going to be 1 only. Only the middle one will be negative. So just write it like this. BC minus F square. Just apply negative here. So since it is HC minus FG, you can write it as FG minus HC. Right. Then we have the HF minus GB, because it will remain same. Only the middle one becomes, because we have applied the negative. In order to find out the determinant, it's quite easy now, because already cofactor we have found out. So you don't have to worry about sign. Just multiply A with the first M11, H with M21 and G with M31. Just and add them. Okay. Or you can do the normal way. So we are doing A into BC minus F square, that is M11. You don't have to take the negative here, as I said. Okay. if you are taking minor, then you are taking negative, because if you take HC minus FG, you have to take negative, because this is, I'm using the minors here, not cofactors. Please remember, this way I am solving it using the minor, not cofactor. If cofactor is there, then you don't have to take negative H, it will be positive H, but you have to use FG minus HC rather than HC minus GF, right? So now you just rearrange it. I hope, now I am doing it with the cofactor. So AHG, just write it here, multiply it with the cofactor of first one, BC minus F square. This is using cofactor, plus H into, already cofactor sign has been taken care. So HF minus HF minus this FG minus HC, and then G into third one, HF minus GB. So the middle one, we didn't care about the sign, we just put plus because it is using cofactor. But previously I just told you about how to do it using the minors. So in both the cases, the final will be ABC plus 2HFG minus AF square minus BG square minus CH square. This will be final, right? I hope you'll be able to do this, right? Now we are taking this seventh one. So it is 4 by 4 matrix. It is 4 by 4 matrix. We just have to see the first column. We don't have to find out the minor or cofactor for each and every element, just the first column. So we'll write M11, M21, M31 and M41. These are for the first element of the, you can say first column actually. So M11 will be what? Just forget about the first row and first column. Others you have to write 0, 1, minus 2, 1, minus 1, 1 and negative 1, 5, 0. Right? Now, second row, first column, just leave second row, first column. Others you have to write. It will be minus 1, 0, 1, 1, minus 1, 1 and minus 1, 5, 0 and 3, 1. Third row, first column you have to leave. So it will be negative 1, 0, 1, minus 1, 0, 1 and then 0, 1, negative 2, 0, 1, negative 2 and then minus 1, 5, 0. Then we have M41, fourth row, first column. So leave this, you just have to write minus 1, 0, 1, 0, 1, negative 2, 1, minus 1, 1. Okay. So I have full faith in you. You'll be able to do this this determinant, 3 by 3 determinant you have already learned. Okay. One of this, let me just give you an idea. One of this I am taking, right? So first row I am taking. M11 I am doing it for you. 0 into, so minus 1, 5, 1, 0, minus 1 and then 1, minus 1, 1, 0. Just for the sake of completeness I am computing M11, minus 2 and 1, minus 1 and minus 1, 5. Okay. So this becomes 0. This is negative 1 into 1 into 0, 0, 0, minus, minus, plus. So you get 1. 1 into minus 1 is minus 1. So it will remain as minus 1. Then minus 2, 5 minus, 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 plus. So 1, 5 minus 1. So it will be 5, 5 minus 1. So it will be 4. 4 to the 8 is 9. Minus 1 minus 8 is minus 9. So you get minus 9 here. So you'll find out I'll just write the minus 9. Here you will get, I hope you will be able to do it. It will be 9. The next one will be negative 9. And this will be 0. These are the minors. In order to find out the cofactor, negative 1 to the power 1 plus 1, it will be 1 only. Negative 1 to the power 2 plus 1, it will be negative. So it will be negative 1 to the power 3, it will be negative 1 to the power 4, it will be negative 1 to the power 5. So only the first one, only the second one will be negative and fourth one. So M21 and M41 will be multiplied by negative, other will remains the same. So you get negative 9, negative 9, negative 9 and 0. So minus 9 and 0. Okay. You got it? Now in order to find out the determinant, take the first column and multiply it with the values, that is the cofactors. Okay. So we are going to find out, or you can use any of the row. You can use 2, minus 1, 0, 1 also. It's up to you. So there is a solution being given here, but rather I will try to do the way we have just learned. that I'll use, excuse me, I'll use the first column 2 into minus 9, then minus 3 into minus 9. I will not consider the sign, only the values multiplied by the cofactors. So 1 into minus 9 and 2 into 0. I'm using the first column, okay, I'm opening it with the first column, 2 into 0. So to get minus, that is 18, and 9 is 27, that will be positive 27, then we have minus 9 here, so it will be 18, 27 minus, it will be minus 27, 27 minus 27 is 0, so the answer will be 0, the determinant will be 0 here. Evaluate the following determinants. Since this is a 2 by 2 matrix, so if this is 2 by 2 matrix A, B, C, D, you just have to do A into D minus B into C in all of it. So first we'll take the fourth one is from CBSE to 008. So the first one we are doing x, negative 7, x and 5x plus 1. So all of these you have to do like this, just multiply these two like x into 5x plus 1 and subtract it with the multiplication of other two. Cross multiplication, you can say, a way of cross multiplication. So I'm just making it plus because negative is already there. So minus 7 into x, so minus plus I have done 7 into x. So it becomes 5x square plus x plus 7x. So you get 5x square plus 8x. So this is the answer. I'll just show you how you have to do it exactly. Now second one we are taking. Cos theta and cos theta is cos square theta. Then we have negative minus. Minus sin theta and sin theta is minus sin square theta. So minus will become plus. So minus sin square theta. You know sin square theta plus cos square theta is 1. That is equal to 1. Now we have cos 15 and cos 75. So cos 15 into cos 75 minus sin 15 into sin 75. Sin 15 into sin 75. So we'll use a relationship here. The relationship is sin 90 minus theta is cos theta, or cos 90 minus theta is sin theta. This is what we have to use. How it is going to be? See, cos 15 and cos 75. This is sin 15 and sin 75. Now you can really see that sin 90 minus theta is cos theta. So you can write sin 15 as what? Sin 15 as 90 minus 75 and 75 as 90 minus 15. So sin 15 I am writing it as 90 minus 75 because 90 minus 75 is eventually 15. This is going to be cos theta, cos 75. It will be cos 75. So in place of sin 15, you can always write cos 75, right? Similarly, for sin 75, you can write it as sin 90 minus 15, and that is going to be cos. This is going to be cos 15. So what it will be? Cos 15 cos 75 minus, this is cos 75. I'm writing it here, and this is going to be cos 15. And you see, both are same, so it's 0. They both are same. They cancel each other out. And this is CBSE 2008. So in the complex theory, complex mathematics, we always write I square equals negative 1. I. Okay. So same thing we are going to do, cross multiply and subtract these. So A plus IB multiplied by A minus IB. And subtract this with C plus ID into minus C plus ID. C plus ID, and you can always write it as ID minus C, but whatever is given we are writing it. Okay, let us take the first one here. A into A is A square. Then A into IB is minus AIB. Then multiplying IB with A, so it will be again AIB or IBA you can write because they both are same. Minus IB into IB, B square is there, I square is minus 1. Remember, I square is minus 1, so I am making it as positive. Minus minus become positive. So this becomes plus B square. Now, IBA and AIB, did you see they are exactly similar? So you can cancel them. Just cancel them out. What do you get? A square plus B square. This is what you get. Right. Coming to the other one. Negative we'll see later. Minus sign will be said later. So minus C square here. And C into ID is ICD. CID you can write it as ID and C is minus CID. And ID into ID is, you have I square as minus 1, D is D square. I square is minus 1, so you just make it minus D square. Okay. So you can just cancel these two out. This is minus C square minus D square. You can take negative out, C square plus D square, right? So negative was already there. So it becomes positive because you are subtracting it. a square plus b square, just add it to it. Final will be a square plus b square plus c square plus d square. Evaluate this. So either you find you can find some way to easily solve it, okay, some commonality or something, but we have to find out the determinant and we have to square it. But let me tell you in the beginning that this determinant is going to be 0. How it is going to be 0, you'll just see. I'll just expand it. You can use any of the row, any of the column to expand it. But the simplest we see is the first row. So we'll expand it using first row. 2 into something minus 3. Minus 3 why? Because always the sign depends on minus 1 to the power I plus j. Since the number 3 is at A12 position, so 1 plus 2, minus 1 to the power 1 plus 2 is minus 1 to the power 3, that is going to be negative, right? It will be negative. So it will be 2 and here minus 3 and here it will be 7. Let us write it as 7. I'll write it as plus 7. Okay, now wherever this 2 is lying, which row and which column, you have to leave it. So you'll get 17, 5 and 20, 12, minus 3. So you leave this row and column, you get 13, 15 and 5 and 12. In this 7, you are going to write, so leave this row and column 2, 3, 7 and 5, 7, 5, 12. You get 13, 17 and 15, 20. Okay. Now see here, 17 into 12, this is going to be 204. 5 into 20 is 100. So 204 minus 100. 13 into 12 is going to be 156 and 5 into 15 is 75. You just write it here. 13 into 20 is 260 and 17 into 15 is 255. So I hope you will be able to calculate it. The answer will be 0. So if it is 0, just square it, you will get again 0. Because determinant of a square is nothing but determinant of a whole square. First find out the determinant and just square it. Now show that this is equal to 1. Okay. So what we'll do is we'll again apply that relationship, that is cos theta is sin 90 minus theta, cos 90 minus theta is sin theta, and sin square theta plus cos square theta is equals 1. So we are cross multiplying sin 10 into cos 80 minus sin 80 into cos 10. Because it is minus, so we'll make minus minus as plus. Okay. Now you see here. So we just did sin 90 minus theta is what? Cos theta. We just did that question. And cos 90 minus theta is sin theta. So cos 80 can be written as, it can be written as cos 90 minus 10. This is not sin. I am just changing it because this is wrong. So cos 80 can be written as, this is cos 90 minus 10. I am just erasing it. So cos 90 minus 10 is same as cos 80. Plus cos 90 minus theta is sin theta. It will be sin 10. So in place of cos 80, you can write it as sin 10. Similarly, in place of cos 10, you can write it as sin, or you can write sin 10, sorry. Sin 80 as sin 90 minus 10. And sin 90 minus theta is what? It is cos theta, cos 10. You just write it here. In place of sin 80, write cos 10. So sin 10 into sin 10 is sin square 10. Here we have cos 10 into cos 10 is cos square 10. Sin square plus cos square is 1. Cos sin square plus cos square is 1. Okay. So this question we have to do it by two methods. First method is quite clear to you. Use any row, use any column and just open it. For example, I'm going to tell you the first one first. So 2. Now please remember this is A11, A12 and A13. So we'll always use the sign depending upon what is minus 1 to the power I plus j. I and j are the row and column number. So first one and last one will become positive, middle one will become negative. So I'm writing minus 3 here. 2 and negative 3 and minus 5, since it is already minus 5, we just write minus 5. Actually, the sign will not change because it will be minus 1 to the power 1 plus 3, that is going to be 1 only. Okay, 2 here. Now, what you have to do is, wherever this 2 lies in the intersection of row and column, leave that and write the other things here, like row and column leave. You have to write 1 minus 2, 4, 1. 1, 4, negative 2, 1. And this will be, see, leave this 3 row and column, you get 7 minus 3 minus 2, 1. And minus 5 row and column, you get 7, 1 and minus 3, 4. Right? Then 2, 1 into 1 is 1 minus 4 to the 8. So it will be plus. So 2 into 9 it will be 18. Minus 3, 7 1 is 7, minus 3 to the 6. 7 minus 6 is 1. No, it will be negative only. 7 minus 6 is 1. Okay, minus 3 into 1 it will be. Now minus 5. 7 4 is 28 and minus of minus is plus, so 28 plus 3 it will be. 28 plus 3 is nothing but it's 31. So 5 into 31. 9 is 18 minus 3 minus 5 is 5, 5 is 15. So when you calculate it, it is going to come as negative 140. Right? This is the first one. Now the second one is called as Saras, or you can call it as Saras. Saras or Sarus, whichever way you want to pronounce it. The method is, it depends on the pattern, okay? We'll find a pattern. So I'm writing the determinant first, or the matrix first. 2, 7, minus 3, 3, 1, 4, and 5, negative 5, negative 2, 1. This is what we have. Now you have to replicate or write the first two columns again. That is first, second, third column. You have to use this one, first and second column, write it again. That means 2, 7, and minus 3 has to be written. And then we have to write 3, 1, and 4. Okay. Now, what do we do? It will be very easy. Multiply this 2 into 1 into 1. I'll just show you. Let me change the color. Okay. 2 into 1 into 1. This one, first one, plus 1 into 1, then plus. Again, the next line, parallel to it. 3 minus 2 into minus 3. So 3 into minus 2 into minus 3 plus minus 5 into 7 into 4 plus minus 5. I'm just making it minus because already minus is there. Minus 5 into 7 into 4. But you have to do plus 7 into 4 into minus 5. Right? Okay, all of these. Then subtract it from the opposite direction. The line in the opposite direction. That is, see what we have to do is, this is minus 5 into 1 into minus 3. Minus 5 into 1 into minus 3 plus 2 into minus 2 into 4. You just subtracted 2 into, I'm just making it negative because my negative 2 is there. So 2 into 2 into 4 and then 3 into 7 into 1 plus 3 into 7 into 1. Right? When you compute this, it's going to come as 140, negative 140. So I hope two columns you have to repeat and use this method in order to find out the determinant easily. Or either way you want, this is up to you because there are multiple methods to solve the determinant of a matrix. Evaluate this thing. So we'll do it one by one. We'll do it properly, okay? So this is the answer if you really want to do it by yourself, and you can just recheck whether you have done it or not correctly. It is an NCERT question, so we are going to do it. So open it using the first row, 0 into, I'm not writing anything because ultimately it will be 0. Minus sin alpha, I'm using the second 0 minus 0 sin alpha and minus cos alpha. So minus sin alpha, and when you write this minus sin alpha and cos alpha, and it will be sin alpha, sin beta and 0. Minus will be plus. No, it will be plus actually. So we are writing minus here. It would have been plus, but because since it is minus cos alpha, I am writing it as minus cos alpha. It will be minus sin alpha, cos alpha and 0 and minus sin beta. Right. So it is 0, so just remove it, minus. Now sin alpha, this is going to be 0 and 0 minus. See, it will be 0 minus sin beta and cos alpha. So it will be negative. So cos alpha sin beta, negative cos alpha sin beta, minus cos alpha, and this is going to be minus sin alpha and minus sin beta. Minus become plus, so it will be sin alpha and sin beta. And this is going to be 0, so just leave it. What this final will be, minus will be plus. So it will be sin alpha, cos alpha, sin beta. And the second part will be cos alpha, sin alpha and sin beta. Now you see, cos alpha is there, sin alpha is there, sin beta is there. So ultimately, it will be 0. Evaluate this. So this is also an NCERT question, so we are going to do it. So if you are from NCERT, then you don't have to do NCERT because already ID Sharma has enough question which can, that includes NCERT questions actually. So let us do it the way we normally do. We'll use the first row. See, using the second row is quite easier because one of the part will be removed. So I'm using the first row. So I'm just writing in the short form. I'm just writing C alpha for cos alpha So this will be cos beta, and we'll write something here, that is row and column, just leave it. It will be cos beta 0, sin alpha, sin beta. This will be cos alpha. Now minus, this is cos alpha, sin beta, and then inside this we have, leave this, so minus sin beta, and then we have 0 and sin alpha cos beta. This is going to be this is going to be cos alpha, plus minus sin alpha, so I am writing it as negative, and this is going to be minus sin beta, and cos beta, this is going to be sin alpha cos beta, and here sin alpha sin beta, sin alpha sin beta, right? Okay, so let us just see once more, cos alpha cos beta, everything is correct or not, because in this kind of question, the question doesn't have that worth. The worth is that how do you do it properly, because sometimes cos alpha may be confused with cos beta, sometimes negative signs will be missed. That is how normally we do mistakes. But once you write this, just recheck it. So we'll do one by one. That is first part we are taking, first I am taking. So first one will be cos alpha cos beta. Inside this we have cos beta cos alpha, and minus something with 0, 0 into 0, something is 0. So this finally will be cos alpha cos beta cos alpha. Actually it's cos square alpha, it's basically cos square alpha and cos square beta, right? The first one is done. Coming to the second one, this is minus cos alpha sin beta. Here we have minus sin beta cos alpha. This will be 0, so minus minus will be plus. Just write sin beta and cos alpha. Okay, so this cos alpha and cos alpha is going to be cos square alpha. So I am adding it, cos square alpha and sin square beta. Sin square beta. So two of it we have done. Coming to the third one. So we will do this, negative will just take sin alpha here. So let us multiply it here. I am doing it here. I am doing the third part. So this is minus will take just now, but we have to consider this sin alpha. Multiply this. It will be minus sin beta sin alpha sin beta. And here cos beta minus cos beta sin alpha cos beta. Okay. Now what do you see here? Minus this sin square beta minus sin square beta sin alpha. Here we have cos square beta and sin alpha. So sin alpha cos square beta. Okay. Now you can take minus, sin alpha is already there. Already we multiplied it, right? So just multiply sin square alpha. Minus is already there. We can take minus common. So when we take minus common, minus is already there, it will be positive. So we'll write just this with positive. Sin alpha, I am multiplying it. So it will be sin square alpha, sin square beta. And sin square alpha, sin square beta it will be. And then we have sin alpha, again sin square alpha and cos square beta. Right. Okay, we'll take cos square alpha and then we take cos square alpha common. So cos square alpha we take common, it will be cos square beta plus sin square beta, or sin square beta plus cos square beta. Okay, from the second one we can take sin square alpha common, and inside this we get sin square beta plus cos square beta. So sin square beta plus cos square beta is 1, sin square beta plus cos square beta is 1. Both of these are 1. Now we are just left with cos square alpha plus sin square alpha, and sin square alpha plus cos square alpha is 1. So there you get 1, right? Okay. Now here we have two matrix. We have to find out the determinant of A multiplied by B and individually A and B and multiply them. So we have to see whether they both are equal or not. Okay, let us see A. It's simple 2 by 2, so it will just cross multiplication. But we have to multiply A and B, then we have to do the determinant. So 2, 5, 2, 1 here, 4 minus 3, 2 and 5 here. So just take the multiplication of matrices. So this will be 2 into 4, 8, 5 into 2, add it, 8 plus 10. Then 2 into minus 3, that is minus 6, and 5 into 5, that is 25. Okay. Now we have 2 into 4, that is 8, and 2 into 1, that is 2. Now 2 into minus 3 is minus 6, and 1 into 5 is 5. So what is the final answer? It's 8 plus 10, 18, 25 minus 6 is 19, 8 plus 2 is 10, 5 minus 6 is negative 1. So just take the cross multiplication, 18 into minus 1 minus 19 into 10. So it will be negative 18 minus 190, minus 18 minus 190. So just add these two and take a negative sign, it will be minus 208. Now we'll take A and B separately and try to find out the determinant of each of them and then multiply. What is A? Determinant of A, 2 into 1 minus 5 into 2. So it will be for 2 into 1, 2, 5 2 is a 10, 2 minus 10 is minus 8. This one 5 4 is a 20, minus will become plus, 3 2 is a 6. So this is going to be 26. Now this determinant of A is negative 8, determinant of B is 26, and just multiply these two, you get minus 8 into 26, and that is going to be minus 208. So we verified that the left hand side is equal to right hand side. Next one is 3 into A, that is multiply a scalar 3 with this matrix and find out the determinant, or find out the determinant of this matrix and multiply it by 27, whether they both are equal or not. So we'll multiply 3 with each of them. That is, when we multiply a scalar, it will be multiplied with each and every element of the matrix, right? So this 3 3 3 3 9 is the 27, 9 3 is 9, 9 3 is 27. That is how it comes. So I am just opening it. I am doing the right hand side first, 27A. So 1, I am opening it for the first row, 1 negative 0 plus 1. So 1, we have known about minors and cofactors, so I am just using the minors now. So 1 into, what do we get? 0, just leave it, because ultimately anything multiplied by 0 is going to come as 0 only. So 1, when we take 1, it will be 1 0 2 4. 0 I am not taking, and then 1, it will be 0 0 1 0. This will become 1, 4 minus 0. So 1 into 4, and this becomes 0 minus 0. So that is going to be 0. See, it will be 1 into 0. See, 0 minus 0 into 0 is 0. Minus 1 into 0 is what? It's 0. 0 minus 0 will be 0. When it will be multiplied by 1, it is going to be 0. So essentially, we are going to get only 4 into 1 here, right? So this 4 into 1 will get us 4. And then as I'm taking the right hand side, we have to multiply it by 27. So what we have to do is 4 multiplied by 27, and that is going to be 108. I'll just show you how it happens. I'm just saying that this will be 0. 0, 0 into 0 is 0. 1 into 0 is 0. 0 is 0 is 0. 0 into 1 is 0. So now we have to multiply it by, this is determinant of A, and that is going to be 4 multiplied by 27. As I just said, multiplying by 27 will give you 108. Okay, so this is the right hand side. We got 108 here. The left hand side, we multiply the matrix by 3. So each and every element will be multiplied by 3. 3 into 3 0 3, 1 3 6, 0 0, 4 3 is 12. Now we'll find out the determinant of this. So same thing, we'll operate with the first row. 3, something will come, that is the minor will come, minus 0 into minor will come, and plus 3, the minor of 3 will come. So it will be 0 3 6 0 12. Middle one, just leave it. Then you get 3. So you get 0 0 0 3 0. Now this is 0. So this will be 0. Minus 3 into 0 is 0. So 3 into 0 is going to be 0. So these two parts, they are 0. We just have to do 3. 3 into 12 is 36. Minus 6 into 0 is 0. So 3 into 36 will come. It is 108. It's 108. Okay. So you have to do it like this. Find the value of x if. So we have to, this is all 2 by 2 matrix. So we'll multiply the cross multiplication. It's just a cross multiplication. So we'll try to find out the value of, see, they are all determinant, not matrix. Matrix will always be in the square bracket. If you have straight lines, parallel lines, that means you have to find out the determinant. So I'll do it right now here only. 2, 4, 5, 1. This is going to be 2x, 4, 6x. Okay. Now, this is determinant. So 2 into 1 is 2, minus 5 4 is 20. Here 2x into x is 2x square and minus 6 4 is 24. So 2 minus 20 is minus 18. So we'll take it here. It will be 2x square minus 24 plus 18. So 2x square and what do we get? 2x square minus 18 minus 24 we'll find out. 18 minus 24 is simply, it will be minus 6. So 2x square minus 6 equals 0. Now divide both sides by 2. You will get x square minus 3 equals 0. So x square minus 3 equals 0. That means, what do you get? I'm just dividing it by 2. X square minus 3 equals 0. X square will be equal to plus minus under root 3. That is how the values will come. Let us do the another one quickly here only. I'll do it directly. You know how to do it now. So here 2 5s are 10, minus 4 3s are 12 equals x into 5, 5x, minus 3 into 2x, 6x. So we get 5x minus x is minus x, 10 minus 12 is minus 2, minus minus cancels, x will be equal to 2. Now third one, 3 into 1, 3, minus x into x, x square equals 3 was a 3, minus 4 to the 8. So this becomes, directly you will get x square here. 3 gets cancelled, minus x square is minus 8, minus minus cancel, x equals to 2 root 2, but it will be plus minus 2 root 2. So x square equals here, basically under root 8 is what? Under root 4 into 2. 4 will come outside 2, so it will be 2 root 2. Okay. Okay, now this one we are going to do, or fourth one is also remaining. So let us do the fourth one also. This is 3x into 4. So fourth is a 12x. Minus 7 to the 14. This equals 10. So 2x equals 14 goes there. 12x equals 14 plus 10 is 24. Both sides divide by 12. That is going to be x equals 2. So this is how it comes. So there is one more. I'll show you the fifth one. We are doing the fifth one. X plus 1 into x plus 2. X plus 2 minus x minus 3 into x minus 1. X minus 1 into x minus 3 equals, fourth is a 12 minus 1 into the minus 1 is minus 1. So minus minus becomes plus 1. So 12 plus 1 it will be. Okay, let us calculate. X into x is x square plus 2x plus x plus 2 and minus. This is x square minus 3x minus x plus 3. Okay, we'll do this later. X square plus, this will be 3x plus 2. And this is x square minus 4x plus 3. Minus x square plus 4x minus 3. I've changed the sign. Now x square gets cancelled. 3x plus 4x is 7x. And then we have this is minus 1. But on the right hand side we have 12 plus 1, that is 3. So this becomes 13 if you take on the left hand side or right hand side, whichever. 7x equals 14. Divide both sides by 7, you get x equals 2. Okay. This is CBSE 2013 question. Find the integral value of x if. Now we can easily find out the determinant and we'll equate it to 28. Now we will open it using the first column, not first row. X square into whatever is coming minus 0 into, because first column we are taking, right? Because this is second row, first column. So 1 minus 1 to the power 2 plus 1 will be minus 1. That is why I have written minus. Minus 0 into something and plus 3 into, what do we get? Now let us see the minors of all these. So x square, it will be 2, 1, 1, 4. And then we have I'm leaving this 0. 3 will be x1, 2, 1. So x1, 2, 1. Okay. Now, so let us just take it, because I'm leaving the middle part, that is 0, because it is going to be 0. So what do we get? X square, 4 to the 8 minus 1. I'm leaving it. This becomes 3x minus 2. So what do we get eventually? 8x square minus x square. 8 minus 1 is 7, so we can write 7x square. And this is 3x minus 6 equals 28. So what do we get? 7x square plus 3x. 28 goes here. 28 minus 6 is minus 34. Okay. Now what we have right now, the expression is 7x square plus 3x minus 34. Now we will try to find out, rather than making it as a factor, let's do it using the Sridharacharya formula. Minus b plus minus under root b square minus 4ac by 2a. So we'll get two roots here. We'll equate this with ax square plus bx plus c. So this minus b minus 3 plus minus under root b square, it is 3 square minus 4 into ac, 4 into 7 into minus 34. So this will become, see, minus there, so we'll make it as plus 2a, 2 7s are 40. Okay, so it will be minus 3 plus minus. Now when you compute this, let me tell you, it will be 9 plus 4 into 7 into 34. So finally it is going to be 961. Even if you compute, let me just tell you, it will be minus this 961. And when you take the root of this, what do you get? You get 31. You just write 31 here. And in the denominator will be 14. So one time we will take minus, one time we will take plus. So minus 3 plus 31 by 14, or minus 3 minus 31 by 14. So here you get 31 minus 3, that is 28 by 14. Here you get minus 3 minus 31, that is minus 34 by 14. So this is minus 17 by 7. We are leaving minus 17 by 7 or minus 34 by 14 because it is not integer. We'll take x equals 2 only. Okay, you got the idea? Because in the question it is being said specifically, find the integral value of x. So x is minus 17 by 7. This is not an integer, but x equals 2 is the integer. Okay, this is how we have to do it. Okay, the next one. For what value of x the matrix A is singular? Now what is singular matrix? The determinant of a matrix, if it is 0, then the matrix is singular. That is, this is the determinant. So we'll find the determinant and put it equals 0. So 1 plus x, 3 minus x. Here you get 7 and 8. Now take the determinant of it. 1 plus x into 8. 8 into 1 plus x minus 7 into 3 minus x. So this is equal to, this has to be equal to 0. So 8 plus 8x minus 7 3 is 21 plus 7x. So 8x and 7x is 15x. And 8 minus 21 is this 13. So 15x will be 13 by x will be 13 by 15. So this is how singular will come if x is this. Now we are taking the second one. Same thing we are going to do. That is, the determinant of A should be 0. Then only matrix A will be singular. So x minus 1, I am opening it through first row. So x minus 1, what will come? X minus 1, 1 x minus 1. Minus 1, that will come 1 1, 1 x minus 1. 1 1, 1 x minus 1. Then we have the third one, which is again 1 plus 1. And 1 1, x minus 1, 1. Okay, so let us multiply. So x minus 1 into x, this is going to be x minus 1 whole square minus 1. So basically it will be x minus 1 into x minus 1 whole square minus 1. So the second one is minus 1. 1 into x minus 1 is x minus 1 minus 1. So it will be x minus 2. So this is x minus 2. Similarly here, this will be 1 into 1 is 1. X minus 1 is x minus 1. So 1 minus x minus 1. This will be 1 minus x plus 1. So this will be 2 minus x. So just write 2 minus x here. Right. So we'll deal with these other two parts later, but this one we'll do first. So this is x minus 1 whole square. A square plus b square minus 2ab. So x square plus 1 square minus 2 into x. Okay. Then we have minus 1 also. So 1 1 gets cancelled. You get only x square minus 2x. So x square minus 2x, you have to multiply it by x minus 1 also. So x minus 1 into x square minus 2x. What do you get? X cube. And then we have minus 2x square. Then we have minus x square. And then we have minus minus plus 2x. So finally what we get? X cube minus 3x square plus 2x plus 2x. Now we open this. Minus x plus 2. And this is plus 2 minus x. Now this 2x cancels with minus x minus x. Okay. Then you get this 2 and 2 becomes 4. So what do you get? X cube minus 3x square plus 4 equals 0. Now how do you do this? There can be multiple methods. Either you write x square minus 4x square plus x square plus 4. If at all it solves the problem. Okay. If at all it solves the problem, then you can do it. I'm just giving an idea that this can be also an approach. You can write it as x square minus x cube minus 4x square plus x square plus 4. But we will see, we are not getting anything. This kind of operation will not be of any use. So I'll give you another method. There can be multiple methods to solve it if you know it. I'm just giving you some other method, because one method we tried and it failed. So we will write this as like this. See, x cube plus x square, then we can write it as minus 4x square plus 4. Okay, now you can take x square common, x plus 1 will be there. From here you can take minus 4 common, and minus 4 common, it will be x square minus 1 inside. So x square minus 1 will be inside. Just write x square minus 1 here, minus 1. Okay. Now x square x plus 1 minus 4, x square minus 1 can be written as x square minus 1 square, that is x minus 1 x plus 1, a plus b a minus b. Okay. So now we can take x plus 1 common from here. X plus 1 you can take common. So you take x plus 1 common. What do you get? X square minus 4 into, this is x minus 1. Because x plus 1 we have already taken common. This is x minus 1. Okay, x square minus 4x plus 4. And this is nothing but, see, if you do it, x square minus 2x plus 4, x minus 2, you can take minus 2 common from here, x minus 2. So you get x minus 2 into x minus 2, which is nothing but x minus 2 whole square. So you get x plus 1 and x minus 2 whole square. Now you can put it as 0. So what do you get? X plus 1 equals 0, that means x is minus 1. X minus 2 equals 0, that means x equals 2. So this is the solution. Okay. Okay, this is all about this exercise. Thank you so much. Take care of yourself.